Okay, we're on this question over here. I'm talking about the SAGE code. And again, the question is like 10 to the x exponential equals this log base 10 of x. The curves don't intersect in a real space. And the bottom line, they say if you translate these guys over here, they'll meet at a unique point. And how they translate these things over here, they're shifting down the exponential until it hits the log function at a unique point, which means a point of tangency. We already went through the the derivation of the formula. And what I'm going to do is use Newton's method now. So let me do that. And I'm going to go to my terminal. I'm going to launch SAGE. And again, SAGE is an open source platform. It's on my system, it's running under Python 3.11.1. So what I want to do is I just want to, maybe just clear the screen first. And then I'm going to type in reset. And this gives me a clean slate. And then what I'm going to do is type in the function. Now, what function are we typing in? We're typing in this function over here. All right? So I'm going to say f of x is equal to x times. Now, the natural log in SAGE is just, excuse me, log. All right? So it's log 10, but that thing is being squared. And then, of course, times 10 to the x minus 1. All right? The next thing I want to do is I want to type in another function related to this one over here, and I could call it the Newton method function. All right, what's that going to be? It's going to be x, and that's going to be my initial guess, minus the function, evaluate that initial guess, divided by the derivative of f with respect to x. Again, evaluate that number x. All right, what am I going to do now? I'm picking a guess point on it, and the guess point, you may wonder how I'm getting a guess point over here, is I look at a picture. All right? Maybe I should do that. I'll plot. I'm going to plot the log function. So log, whoops, I'm going to type that in. I'm going to the log function. But you remember that's natural log. But in SAGE, I can tell you what the base is. The base is 10. And I also want to graph out 10 to the x. All right? And then I'm going to close that out. And, it's a rough graph. Let's see what happens. And what happens over here, it's going to plot it out. And I see that. And then the question is, like, if I move these things down and I keep moving this down over here, I'm going to say, if I move this green curve down, it's going to eventually here. And if you look at this thing over here, it's around 0.1. I'm not saying it is 0.1. I'm just saying it's around 0.1. So I get an idea when I shift this down, the x can be about 0.1. All right? So let me go back to my, I'll close this out, and I'll talk about the initial guess. The initial guess is going to be about 0.1. Now what I'm going to do is I'm going to use Newton's method to evaluate this. All right, so Newton's method. Now what I'm going to do is x now is 0.1. And let me just, sorry about that, I need to do that. So I want to evaluate Newton's method, but I want to display the x. I want to claim, though, you're going to be shocked. Whoops, I made a mistake already. X equals Newton's method. Now, again, I'm going to explain this what happens over here. Newton's method is called first, by the way. The value x is 0.1, and then what's going to happen is it's going to assign it to another a place, which is x again. So it just replaces it. Now, if I just type in x over here, you're going to see something pretty bizarre over here. And I don't want that. What I want to do is I want to see a number. All right? And the way to do that is I need to force SAGE to take that x and make a decimal out of it. All right, let me see if I can do that. So I'll put this over here, and I'm going to use .n notation now. And that .n notation is numerical approximation. All right, hit the return now. Now what do I get there? It gives me a guess. I'm not sure if that's the correct solution to the problem, at least within the precision of the machine. I can hit the up arrow and do it again. I notice there's a change, by the way. So where do you see the change? It's actually in the ending digits. All right, the beginning looks pretty good, by the way. But let me do it again. I'm going to keep looking around and see when it changes. Well, it changed a little bit there too, right? Let me keep going. Well, you know what? It appeared not to have changed at this point. And what is it saying? It's saying that really the f of x there would produce a 0 there, all right, which is what we're looking for. All right, let me just hit it again. And it's still saying it's no change, by the way. Now, someone says, what were you really looking for? I was looking to get the a in the problem, right? So I want to go through that with you. And it's this equation over here that will give me the a. all right? So I'm going to say A is equal to, right? Now I'm using A as like this placeholder, all right? So what's A equal to? Well, it's equal to 10 to the x, and you're going to see something bizarre here too, by the way. So A is equal to 10 to the x, and that x is that 0.137, yada, 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 all right? Let me just point this out to you. Although you may think x looks like that, it doesn't. This is what x looks like. That's crazy looking, right? All right, so let me clear the screen again. What I want to do is I want to do A is equal to 10 to the x. Again, I'm looking at this equation over here. Minus log x base 10. All right? And when I hit return, I got the A now. Again, if I type the A in, what does A look like? A bizarre number. So what I need to do is I need to approximate the A to get a number out of this thing over here. So I'm going to say A and then dot N. Whoops. Again, N stands for numerical approximation, and it's going to approximate it. And again, you might say, what is it doing over here? It's actually looking at this very long, really long numerical answer over there. Crazy looking, but it does approximate it to 2.34. All right, so I'm going to say over here, we get these numbers over here for you, and all the code's down there for you as well. I also put a helpful graph down over here. And what's that graph going to be? Well, the point at which it intersects, we figured that out using Sage. It's this number over here. And then the other value we're getting over here is the point where they intersected over here. And that's really the shift, the A. And all I did is I typed in the A. So how do you type in that A? Do you actually type it in? No, what I do is I copy paste it, and then I just type it into that grapher software to plot it out. And we're done. Thank you.